Hello, my name is John Richter. I'm one of the directors here at Financial Mechanics, and welcome to this video tutorial on debt repayment sculpting. What we're going to look at here in part one is a situation where we do not have circular logic, and where as a result we will not need macros to come up with a practical solution to our requirements. We'll be able to use the inbuilt Excel goal seek tool to come up with an answer and therefore simplify matters somewhat. And in doing this, I think we're going to dispel some misconceptions about the requirement for having a macro in all circumstances where one needs to sculpt debt. So with that by way of introduction, let's start first by talking about the periodic debt service cover ratio, or DSCR for short. It's important to kind of focus on the aspect that this is essentially a cushion for how much cash flow is generated in any given period over the amount of debt service owed. In a situation where that cover ratio is below 1, there will therefore be a requirement to draw on cash reserves. And if those cash reserves are insufficient, in fact, debt service will not be payable. So if there's not a cash balance or a debt service reserve account that's properly funded, you will likely be in default as the borrower. And from that position, I think it becomes fairly clear that the minimum debt service cover ratio that you might see over the life of the debt is somewhat of a pinch point, arguably the highest risk position of any given period, because it's the thinnest point in the repayment profile. And therefore, that begs the question how much you maximize the minimum. Because if you maximize that minimum ratio, you might, if you were a banker, think that you're somewhat you're minimizing risk. You're de-risking things a bit. And from that point, I think it's useful to sort of take a look at an actual chart. So let's flip over to Excel. So here we have a repayment profile causing a somewhat variable periodic debt service cover ratio with no real attempt at sculpting. The repayments, of course, do in fact repay the debt. You can trust me on that part of it. And by looking at this, you might sort of tell yourself, well, if we kind of push up some of these minimums by kind of borrowing from the healthy ratios, by essentially paying less in principal repayment where the cover ratios are lower than some average line, borrowing from the places where more principal repayment could be afforded to be paid, if you will, we could kind of do a cut and fill operation that might kind of cause you to sort of eyeball somewhere along the 1.4 line, just kind of in rough terms looking at this thing. And if you shuffled these repayments around and otherwise hunted and pecked for numbers, you might, if I recalculate the model, get yourself to some position which in fact does exactly that. We've effectively maximized the minimum cover ratio by making all of the cover ratios the same. Put another way, the minimum equals the average. And that's essentially our objective. And the rest of this video will be focusing on how we get that done in an actual project finance model. So before we wade into the model, I think it's important to quickly describe what it is we do have in this project finance model. First off, we do have a debt service reserve account, and it does look forward to the next 6 months of debt service. We also have a shareholder loan, so we have some subordinated debt sitting underneath both the debt service reserve account and, of course, debt service itself, which is accruing a 12% coupon, which is being paid, subordinate, of course, to the senior debt service requirements. But we are taking a simplifying position that the interest expense on that is not deductible for tax. And this is one of the causes of sculpting being circular, because tax is inevitably excluded before looking at CFADs, meaning that it's deducted from the cash flows as part of the numerator of the debt service cover ratio. We also do have interest earnings on both the retained cash balance and the DSRA. However, we are making those interest earnings subordinate, i.e. below or excluded from cash flow available for debt service. That's not entirely uncommon, particularly for retained cash. It will depend, of course, on the loan agreements for the particular deal. But this, you're starting to see, is another area that does in fact cause these sculpting iterations to become circular. So that's what we've got going into things. So here we are back in the model with our variable repayment profile. And the senior debt calculations at present are not at all complicated. We've got simple interest rate times the brought forward debt balance, getting us to an interest expense. And crucially, the principal repayment is calculated as nothing other than the the amount of senior debt that was used to finance the construction multiplied by a repayment profile that adds up to 100%. We then have a debt balance that repays itself to zero. We'll take a quick look at kind of the profile of that fellow before we get into things. And that's pretty much the picture that we're starting with. So let me delete that chart and let's see what we can do from here. I suppose the first thing I would do is make myself some room to get some code done. So that's a place to start. At this point I'm kind of stuck, so I think it's time for us to consider some algebra. And particularly what I'm sort of starting from is a position that says, well, the debt service cover ratio is equal to CFADs over debt service. We're all pretty comfortable with that. And from that, I might be able to calculate something I'm going to call target debt service by looking at the CFADs and dividing it by a guess, or target debt service cover ratio. So you'll remember we looked at that chart and we kind of eyeballed something around 1.4. So if we just make up, and I might as well use 1.4, we can get an aspect or get an estimate of how much debt service we'd have in any given period that would force the ratio to be 1.4 by simply taking CFADs and dividing it by that figure. So that's a place to start. So working with that script, here we've got target DSCR, and I'll just sort of say guess to kind of make the point. Go ahead and put in 1.4. That 1.4 was just, again, kind of eyeballing along this line. I'm not presuming that's some sort of super accurate guess. We could guess anything. But if that is to be the period by period ratio, it means that if we look at CFADs over debt term, which I think we could probably get from the ratios page because we are calculating ratios here. So I will hunt down CFADs over debt term. We don't want the debt to be repaying any longer than its current fixed term. That will be an import and a counterflow. We get this concept of target debt service. And we decided that was CFADs divided by that guessed ratio. So we'll put that in. And if you want to have a cover ratio of 1.4 in every period, this better be your target debt service. So if we have that target debt service, then we can consider that target principal is nothing more complicated than taking that target debt service and subtracting interest. So let's move on to that step of the process. Again, not very complicated. I'll be very pedantic with the layout, create a link to target debt service, and we'll use the positive form of interest. I'll show that we're going to subtract that to get target principal repayment. So we'll shoot those labels across, and do an A minus B to get what target principal would be, which would imply that 1.4 constant ratio. And when we look at that total, 183,611, just as things are now anyway, we can see that we're not repaying what it is we have to repay. We're not getting that 195.6 million pounds of repayment as things are now. We're only getting 183,611. And that essential disconnect, the fact that we're not repaying what we need to repay, is at the heart of the iteration that we're going to be getting onto here in a few minutes. Essentially, this 1.4 ratio guess that we have is not quite right. So that gets us to the next step to consider. So if we have the target principal, we can then get a target repayment profile based upon looking at that target principal paid in each period and divide back by the initial debt balance. And that sort of B divided by A plan was exactly what we did with the ratio in the first place, so I might as well use some of my fast modeling skills and reuse that calculation block where the A is that initial debt balance, which I can take from this row anchored link here, and what we're looking to use is the target principal repayment. So let me get that ingredient in place. Got some formatting to do here, which is no shade and no import marking. And this then in theory is not target debt service, but is that target repayment profile. And this sort of makes the point more strongly that this fellow here needs to be 100%. And we can focus ourselves on that by calculating the sum of the target repayment profile as a very explicit calculated constant here to focus ourselves on the fact we've got to get that to just that, 100%. So what do we do? Well, we can remember that that target DSCR, that 1.4 that we started with, is an input, which we can guess or set to anything we want and see if we can run that through and keep guessing to get that target repayment profile to add up to 100%. So that seems like a very simple, straightforward approach, which we will attempt next. At one level, I could just try some different numbers, and I think it's important for us to consider that this high ratio is implying essentially less debt service can be paid. And so essentially this 1.4 is too high. And if I were to try 1.35 as a guess, without doing anything too fancy, we'd see we'd be a bit over 100%. Of course, we're not really using the profile yet, and I think the next most important thing for us to do is to replace this current input profile that we talked about at the outset here with this target repayment profile. So I'm just going to create a link to this. And this, you guys might think, is where the model might become circular in many of your own work. Well, so far with the Shift F9, and because we now changed the profile, the interest profile has changed, and that's kind of disrupted things here a little bit. A Shift F9 does not seem to have kicked off any circularities, but we still, of course, have not fully recalculated the model. So the question is, if I fully recalculate the model, do I have a problem? And the answer is no. But we do see that those numbers shifted yet again. And the reason that we do not have a problem in this particular model is precisely to do with that list of qualifications that we put together at the outset. To quickly recap in short, that was that we did not deduct for tax purposes the interest on the shareholder loan, the subordinated debt, and we also put the interest earnings on both the DSRA and the retained cash balance below CFADs. So with those qualifications, this tie-up is not circular. And from this position, we can do exactly as we talked. And one way, of course, is to sort of hunt and peck for different numbers. We're overpaying, so that suggests we could get a slightly higher ratio and try 1.38, do a full recalc. That looks like it's too high, 1.37. Kind of making this up pretty close at 1.37. Okay, but of course that's a bit tedious, and this is our opportunity to use the goal seek. And I think it is important to show some skill here, or some techniques that make goal seek work a little bit better. And what I'm going to type in for a label pretty much explains what we're going to do. We're going to take an amplified set cell delta, okay, to equal 0. Okay, so where I'm getting at here is this needs to be 100% above us. So 1 minus that figure should be equal to 0. But more than that, goal seek doesn't like to get to small numbers. And what we can do is put a big number, different ways to do this, but you could do kind of 10 to the 6th times that quantity. So what I've done is I've amplified the delta so that goal seek has more to hang on to as it pushes things around. And I'm just going to mark that gray because that's our set cell equal to 0. The change cell, of course, is up here. So this fellow here is going to be kind of an iterated input. So I'll just make that tan number, and that's the change cell, if you don't mind me marking. And there's the plan. And efficient goal seek use is to simply do all tools goal seek. Well, in 2007, slightly different route, but you guys won't mind. You eventually get to this box. I'm going to get the box out of the way. Tools goal seek, set that to 0 by changing this fellow and let the model rock and roll. And the question is, does 1.3727 and change, okay, there's a lot of digits under there, but let's just sort of go for, well, why don't we go for 5 digits, because that's kind of interesting as we look at the other ratios. 1.37265, the first thing is, does it repay the debt properly? And essentially, yes, within the rounding level tolerances that we've set our checks to, the debt gets repaid, and the balance is kind of accelerating down here at the back. It looks like there's relatively steeper decline at the back than there was at the front. So a little bit of backloading going on. You know, is that ratio working? And I suppose the proof's in the pudding. And let's look first at the profile. And presto, that will look familiar. So that has gotten the job done. The next thing that's interesting is to go to the ratios page where we have different calculations, which I'll mark off. And, you know, it's not going to be a rocket science to sort of figure out that our average and minimum is 1.37265. But we might be slightly surprised at some of the other results that we'll see on the ratio sheet. So let's go have a look at that here real quickly before we wrap up. So here we are with a minimum of 1.37265. So let me just kind of mark that. Oh, I don't know, what color should I pick? Why don't I say green to kind of highlight it. Simple average, so just looking at the average of the ratios, which we have here as the crap ratio. You got to kind of admire the unit labeling. But that shows that it won't matter that the average ratio is calculated improperly if at the end of the day you're going to get flat cover ratios across the profile. It's not going to make any difference to look at the 12-month. Okay. Gets a little more interesting down here. It's not going to make any difference with this weighted average, and it's not going to make any difference, and believe it or not, the initial LLCR excluding DSRAs. And finally, if you have your debt fundamentally sculpted properly, the rolling LLCR, and I believe this is excluding debt service reserve accounts, I will double check that probably should improve the labeling there, will in fact also be flat at that same number. You won't get that typical rising profile that many of you are accustomed to seeing with loan life cover ratio lines, because this is an excluding the DSRA balance in the numerator, which would be the normal reporting of an LCR. Okay, but it forces, or it otherwise emphasizes, the point of comparability to the periodic and average and minimum and all the other ratios that we looked at. So it's pretty clear we've gotten the job done. We have all of these ratios the same. With all that work, we could have just, if we're going to end up just sculpting the debt, we could simply report a single ratio. And in fact, you guys will want to consider that. The closer all of those ratios are to each other, the closer the repayment profile is to being flat across the line. That becomes pretty obvious when you look at the difference between the simple average cover ratio and the kind of proper weighted average cover ratio, but maybe less clear to you guys focusing on the LLCR excluding DSRA balances. With that, I'd like to just wrap up by reminding ourselves where we've gotten to. We set our guest input to make that target repayment profile add up to 100, and we determined the goal seek is as good as anything, and that did not require us to use any supporting VBA macros. And from that position, we looked at each of the ratios on the ratio page there. The average DSCR, both the weighted and the simple, the minimum LLCRs excluding the DSCR, the initial LLCR, as well as the rolling LLCR over time. And essentially when we sculpted and got that repayment profile fully sculpted, they were all the same. And I want to wrap up just by emphasizing what we use to simplify, to prevent anything from being circular, what are essentially these two howevers. The interest expense on the shareholder loan was deemed non-deductible for tax, and the interest earnings on both the retained cash and the DSRA were put underneath CFADs. And with that, I'll thank you guys for watching through this, and I hope it was useful. Bye for now.